Hey Mo, can you hear me?
Yeah, cool. How are you? How you doing? I'm
I'm I'm good. How are you?
good, very good. Just looking like excited for the review the projects.
Great. Here, let me share screen. All right, you can view it. You can share screen now.
Yeah, good, very good. All right. So you, so what you done today? We
Okay,
can,
so
yeah. 1 second. Uh, so this guy here,
so that's two layers.
this one here, we have in divider. So because you want to put the powder in here, you fill this with powder. So how is work here?
And
Uh,
the whole sphere is two layers though, right? That there's an inner sphere that has holes, and then there's an outer sphere, correct?
1 second here.
Yeah.
Uh,
All right, before you close out of that one, let's zoom in. How big is the air gap between the bottom the center? Let's go to the center one right now. How big is the air gap between the sealed off portion on the top and the sealed off portion on the bottom?
Excuse me 1 second.
Yeah, like zoom in like right here. How much space is how many millimeter separation is there?
For interruptions.
It's all good.
All right. Kids are coming over.
Sure thing. So yeah, if you zoom in on the bottom, the
Yeah?
so yeah, uh the bottom one. How much space is there? Yeah, yeah. See, are they touching?
No, no touching here.
No, no,
Nothing.
no. This here. Limit. Can I have access to the mouse?
Yeah, go ahead. You got this. You can see it here better.
Oh yeah, zoom in there. I want to see how much of an air gap there is from the outer hole to the separation line. You know what I'm talking about?
Outer hole?
Outer hole is the spinning mechanism. There's an outer hole and an inner hole. Yeah, that okay, that's the outer hole.
You want to see the
Okay.
gap here?
No, no, the one right above it. Yeah, see the layer line right above it. That's what I'm talking about.
Yeah. To
So
here?
what no, no, no. You were in the right place here. Can I let me share?
Yeah, yeah, go ahead, take a mouse. Uh, Go ahead.
All right, can you see my mouse?
Yes.
This is what I'm talking about. I'm talking about the air gap right
Ah,
here.
yeah, yeah,
Yeah,
yeah.
because remember
Equal.
this is the outer hole, and then
Yeah,
the inner hole is here. Okay,
yeah, yeah, yeah.
what is the air gap right here? Just like
Uh, yeah, I can give you that number right away. Hold on a
yeah,
second. Here, here. You talk about 2 millimeter?
2 millimeter.
Yeah,
Okay, and that's
more?
equal on both sides.
Yes, yes, I did equally.
Okay, maybe make it four,
Four
for
millimeter? Sure.
yeah, I would say. And then can you still see my mouse?
Yes,
So this dodecahedron will
yes.
mount to the outer, the sealed part, not the inner part, the outer part, the sealed part. So it will mount to it. So like if we can have the center of the dodecahedron match up with the center of the rodent coil, and
Yes.
then that's where the mounting happens. So you might have to extend this on both sides and have a dodecahedron on this side too. Yeah.
Oh, I
And
didn't know
have it symmetrical,
that.
right?
Okay,
So everything should be equally spaced, equally this, equally that.
okay.
Okay, and here's another thing I want you to do. Can you add back this layer to the top
Sure,
one real quick?
sure.
I just want to see something. All right, perfect. Yeah. So just real quick, before I forget. So yeah, do the same thing, mounting here, do another one over here, equally spaced. You still can see my mouse?
Yes.
Okay, great. And then what I was thinking was there's so much dead space
I
all
know.
around this. So
Yeah.
I was thinking if you just do this design again and you just the center octahedron with this, how it's mounted like this with the coils, how about you do one here, and do 6 equally spaced? Do you think that's possible? Is there enough space for that?
Six what? Six
Six
what?
of these center octahedrons. So like do the diameter of the center octahedron real quick and see if you can fit them in the surrounding environment, because there's a lot of dead space there, and what we could do is create extra magnetic fields using more center. So can you just do this diameter to here and see if we could fit them
Yeah,
all around it?
yeah, it's doable. So you wanna like let me take the mouse
I
here.
just want to see, yeah, I want to see how much space there would be if we did that, because
Yeah.
that would be a great way to maximize magnetic fields.
So you want to this part
Yeah,
here.
the whole thing, the whole spinning mechanism of just the center, yeah, and copy
Not
paste that.
everything, not
No,
everything.
no, 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 no.
It's
Just the
just
center.
only yeah,
Just
the
that one.
center
Yeah.
with a layer inside.
Yeah. So
Okay,
just that
yeah.
one with all the layers. Could we copy paste that all along the outer edge? Like
Yeah,
here,
yeah,
and
yeah,
equally
yeah.
space 6?
I will
You
see. I will see how far I can go. Yeah,
yeah, can you just do this diameter real
not
quick?
now, not now. I can't do that. It's
Oh,
not,
you can't.
it's
Okay.
yeah, it's not
So
something easy job to do it right away.
right. Okay, so it's not like a simple copy paste kind of
No,
thing.
no, no. You have to make
Okay. Well, after you finish everything else, think about that, because like that would be if there's enough space where there's enough air gap. Well, because remember, this outer hole spins one way and this inner hole spins the other way. So, so first thing we do is add that 4 millimeter gap. Maybe shave off a little bit of this, or you might just have to extend everything a little bit, whatever's easier. And then what I want you to do right now. Okay, so we're about to split off into 2 iterations. We're going to do the alpha, which is still everything how it is, adapting as we talked about. And then the omega is just going to be this part to this part.
I can't see
Send.
close. Yeah,
Do
no,
you see my mouse?
no, 1 second. Let me close here. 1 second, 1 second. Give me the mouse. Give me the mouse.
Oh, okay.
Yeah, give me the mouse. 1 second. Yeah, go ahead. Go ahead. Say again.
Do you see my mouse now?
Yes, I can. Yes.
Okay, so we're going to split off into, this is going to be the alpha. We talked about this. You're going to mount it here, mount it there, maybe add a bunch of these 6 equally spaced out, maybe.
Yeah.
The omega, the one that's already ready to go after you add the 4 millimeter air gaps on both sides, I want you to take the sealed cylinder to the sealed cylinder and then just add a really small sphere just around that with enough air gap for free spinning. That's what omega will be. Does that make sense?
So hold on a second. No, 1 second. I'll go to beef again so you can make sure I'm understanding right.
Yeah.
So you want to having a sphere around this.
Yes. Yeah. So that will be the omega design, just big enough to where you can mount. Can you see my mouse again?
No, go
Just
ahead.
big. Can you see my mouse?
Yes.
So just big enough to have this. Well, after you do the 4 millimeter air gaps, of course, just big enough. The sphere should be as close as possible, 4 millimeters on all sides, with just this little contraption by itself. Okay, and that will be the omega. And hopefully, because this one's done, we can start printing the omega right now, and we might be able to get away without using the Rodin coils if there's enough power generated from just this alone. So that's why we're splitting off to 2 iterations. Does that make sense? So
Yeah.
all you have to do for the omega after you do the air gaps is you just copy this, and then you throw in a sphere and mount it to the sphere as close as
What about
possible
the
with
little
4 millimeter
coil?
air gaps.
What about the coil? No coil here, right? It will become no coil.
For the iteration omega, no. For the iteration alpha, keep this. Does this make sense? So you have 2 project files now. That way we can start printing this one right now.
Okay.
And all you have to do after you do the air gaps is just add a very small sphere for this. Does that make sense?
Okay. Yes. Yes.
Okay. So here's what I want you to do. As soon as we get done with our call, after you figure out the 4 millimeter air gaps on both sides, separate it into 2 project files now. Call the second one omega with just this, with just that. with the spinning mechanism and a sphere, and then send that to me with all of the correct
We are an
materials
alpha.
labeled.
We are
Make
an
sense?
alpha now. Yeah, we are an alpha now, right?
This is alpha with everything. Alpha is everything. Omega is the smaller model with just the inner workings. Okay.
Okay.
So send me Omega as soon as you finish the 4mm spacing. So all you have to do for Omega, remember, is a small sphere, mount it on each side, and make sure the sphere can open at the halfway point. You don't even I wouldn't even bother connecting it. Just like have it, send it two separate files, one with the top sphere, one with the bottom sphere.
Alpha also have the inner 6 pieces, the inner, right? Alpha.
So yeah, that's for alpha.
Yeah.
Alpha has that. Because because there's a bunch of dead space, we have to generate as much power as possible. But Omega, if we can make it fit in just that little sphere with just the inner workings spinning, that is ideal because that would save us so much material. I'm not sure if it will work. That's why it's a split off iteration for Omega. But Alpha is still our primary focus. But Omega is done. You can send it to me right now, right? So after you do the air gaps,
the 4mm gap.
4mm air gaps. All you have to do for Omega is just Can you still see my mouse?
Yes. Where is it?
All you have to do for Omega is take that part and this part and just copy paste that into a new project file and then make a sphere and mount it to it, a very small sphere. Okay.
Sure.
So do that right after the 4mm air gaps. Send all the project files to me labeled very specifically which material it is, right? So remember how we color coded everything? Yes, it was zirconium, blah, 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 blah. Yeah. So the only one you probably don't know is this one is zirconium, this one is zirconium, and then the sphere would be one inner sphere would be zirconium, one outer sphere would be aluminum. Okay.
Okay. All right. All right.
Repeat that back to me.
This one's zirconium.
The inner. Yeah, that is zirconium.
This one's zirconium?
Yes.
Okay. And what this?
The inner part of that is zirconium, and then there's an outer layer that's aluminum. And the inner part that's zirconium has holes for the sphere only. Make sense?
Oh, okay. So can you write it down? Hold on a second. Where is erasing? Where is it? Go ahead. You can have the mouse.
Okay. So can you see my mouse? So this inner layer right here, that's zirconium, right?
Yes. So you
that's
need
zirconium.
This?
And then
this?
Huh?
You need the holes? Zirconium.
No, not here. Not here. Okay. Here doesn't have holes, but here does. This whole sphere and this whole sphere, the inner part has holes. Like you remember the octahedrons with holes, just like that, because this is all powder, right? And this is all powder. So there has to be an inner sphere with holes for powder, and then there's a whole outer sphere connecting everything, which is aluminum. Make sense? So it's just like because the whole sphere is now a capacitor. This is now a capacitor. This is now a capacitor, right?
Oh God, hold on a second. But I still think this one can be nice here. 1 second. I didn't show you this, but here that's how it looking like.
Yeah, so all you have to do is just add one more layer to this where the inner sphere has holes and the outer sphere is just solid, right?
Okay.
So how thick is this now? If it's thicker than 4mm, you could just cut it in half and do half inner sphere, half outer sphere. How thick is it right now?
I think it's better to do half inside. Be better.
Yeah. So, and what's the total diameter of this contraption as it is?
Okay. Let me see.
Yeah, just as estimate.
Yeah. I think I have that.
You just draw a line.
Yeah.
That'll probably work. So I'm working on funding. I'm trying my best. So until we get it, just go easy on the hours, okay?
I did.
All right, thanks, buddy. Yeah, what are we at in millimeters? If you please.
315.
Okay, that's too big. It can't be bigger than like 290. So you might have to just shrink everything. What you can do probably the easiest thing to do is for alpha. Remember, omega, go ahead and send me as soon as you finish the gaps, right? Because it's ready to go. Okay.
Yeah.
So as soon as you send me omega, then you can get back to alpha. So with alpha, to make this smaller, I would just say shrink the rodent coils and make them thicker. You know, like you just shrink them down and make them thick, and then you can make it the sphere like down here. You know, like that size.
Yeah,
Can you see my mouse?
Yeah, I can see.
Okay, so yeah, so like if you, because like here's the mech here. Can you make this clear so I can see how big the mechanism is?
Sure.
Okay, so yeah, if we're shrinking this, you don't have to do all those. Can you see my mouse again?
Yes.
If you're shrinking this, you probably won't have to do all these extra octahedrons. But if you can shrink it, it depends. If you still have space, maybe do it.
You want to make the coil of the up coil.
Yeah. So the coil, if you make it,
shrink it.
Yeah. So because that's what's making this so big right now. So if we can make this diameter coil the same diameter as this, we can make the sphere much smaller.
Yes,
and then do the same thing with the dodecahedron, just shrink it until it's inside the rodent coil.
Yes.
So do that after you send me the omega file so we can start printing omega, okay?
Okay.
So repeat back to me. So right now you're gonna fix the air gaps here.
4 millimeter.
In here for 4 millimeter. Then what are you gonna do? You're gonna pull this mechanism out, send as a separate project file, call it omega, and send that to me with a tiny sphere just big enough to mount it to.
Is the sphere you need a bolts for it, right? You need the bolts for like this one.
I mean, this one I'm not really liking the bolts. Can we go back to that screw design we were doing? Is it too difficult?
Yeah.
To do screws?
Because this one, because you have a divider.
Okay, yeah, then just do bolts then. If that's easy for now, we'll figure it out later. But the problem with the bolts is they mess with the electromagnetic field. So like
zirconium bolt.
Oh, you mean all 3 layers be zirconium?
Yeah.
Okay, that's maybe a possibility. Okay, yeah. So or you can do it. Remember how you mounted the octahedrons where they're like clips together? You could do that same thing just for the big sphere.
But I'm still in this one, the smart way we done. In the end, we have a bolt through, so we have the mechanism.
Yeah, I still don't like that, but I know there's no way else we're doing it right now. We'll eventually find, if we can have a design where there's no bolts and everything's seamless, that's like perfect for me.
Yeah, I mean,
like bolts are always going to be a hard point on me because those are the biggest points that will fail, right?
Look, we are a lot of things we've done here. We have
I know like I don't want to think about it right now. But like I always know bolts are the weakest point of the design because they always fail. We'll figure it out once we start printing if there's a better design. But that's why I want you to send me omega right now so we can start printing. So omega is just this part with the top cylinder and bottom cylinder and sealed cylinder, and then just send me a small sphere to mount it to. Okay, I can do that. Okay, so yeah, do that right after you do the air gaps, and then your next project should be shrinking the rodent coils to the same diameter as this, so we can make the sphere smaller for alpha. Okay. So create 2 project files, one for alpha, one for omega. Send me omega with all the STL files. Send me individually with the right materials name. Okay. Sure, I will. Excellent. All right, buddy. Have fun. Let me know when you send omega if you have any questions. How your representation was a funding good? I'm still waiting to hear back. He's trying to schedule the call right now. That's why we didn't have that last week call. But I'm very confident still. Like I have no doubts we can get it. But until then, just please go easy on the hours. The logged hours. Work 100 hours today if you can, but go easy on the logged hours. All right, buddy. I love your work ethic. We're almost there. We're at the 99% point. Okay. Let's finish strong. Go ahead and send me omega. I'll start printing it. See what we can do, and then alpha. You know what to do, right? Okay. Yes. All right. Thanks. Okay. Great. Yeah, bye. Have fun.
All
We're
right.
we're there, man. We're there. Oh, you when you send me Omega, remember the bolts, you didn't add the bolts yet, so make sure to send me a project file for the bolts. You know how you for the outer hole you have that bolt design. You didn't send me the actual bolts. I don't think you've made those yet, so make sure to send those as
No,
well.
this one you buy it from outside. Doesn't have to.
Yeah. Just anything that you may have missed, just throw it in just in case.
Okay.
And then label it as clearly as you can, like octahedron zirconium or something like that. You know,
Sure.
the easier it is for the STL files to know what I'm actually printing.
No, that's what I'm saying here. I did before. I show you what you have done. Yeah, I have it. I have it separately. I have it separately, so we can having so the 3D print. You see, I do have it. You see the parts of it. I think you are sharing. Okay, you see, I have the 3D print file. All right. To have each material what is inside of it.
Okay, yeah, that's perfect. Yeah. Just do that for Omega, and then yeah, that go back to the other one. That one you were just showing right before.
Okay.
Let me tell you what I was talking about. One more. One more. That one. Okay, stop there. So you see how you have holes there for the bolts? Yes. What I was saying is I don't think you made the bolts yet for the holes. So make sure to make the bolts and send those as a project file too.
Okay.
See what I'm saying?
Yeah. I can do that. Yes.
Yeah. Because there's the bolts for those and then bolts for the outer hole.
You can print it too, yes.
Yeah. You just need to send me whatever the size cylinder is.
Yeah, just
you know?
standard stuff.
Yeah. Okay, cool, buddy. So go ahead and air gap first, then separate alpha and omega, send me omega, okay?
All right, thanks so much.
All right, I'll talk to you later, buddy. If you have any questions, let me know.